So Wednesday, we finished up with the IV flow rates. Of course, IV stands for intravenous. And for IV flow rates, basically what it means is we are infusing fluid directly into the vein through usually a hanging bag. So let's take a peek at these flow rates. Just a little review of what we did last class. So there's several ways to express the flow rate. We can have milligrams per hour, which is very uncommon, along with milligrams per minute, which is usually pretty uncommon. Usually it's set up either as milliliters per hour, milliliters per minute, or drops per minute. And any of those 5 versions, once we have one of them, we can convert to the others. So let's review here. If I have a doctor that orders 5,000 milliliters of fluid over 4 hours. If I'm asking for my flow rate in milliliters per hour, well, I'm simply going to write it out, 5,000 milliliters over 4 hours, just like it sounds. And to get milliliters per hour, I already have those units, milliliters on top and hours on bottom. I'm just going to convert it to a unit rate by dividing by the bottom number of 4. So that is 1,250 milliliters per 1 hour, or 1,250 milliliters per hour. If I want to change that to milliliters per minute, I could use the 1,250 milliliters per hour. I'm going to go back, because if I wanted to go to milliliters per minute, I would probably start a little bit different with my 5,000 milliliters per hour. And before I reduced it, I would probably change it into minutes from hours. So the hours are on bottom here, going to minutes. So hours are going to go on top and minutes on bottom, so they'll cross cancel out. 1 hour is 60 minutes. Hours cross cancel. 5,000 milliliters times 1 is 5,000 milliliters. 4 times 60 minutes is 2,400 minutes. And now we do have to divide that out to get milliliters per minute. 5,000 divided by 240 is 20.83 milliliters per minute. To get the drops per minute, we would have to have some extra information. And usually it's a little bit more in-depth problem. So let's start out with a new problem for that. So let's take a look. And this time our doctor's order is going to be for 4,000 milligrams of medication over a 16-hour period. So over 16 hours. We're going to look at our label here. And on our label, it tells us that this is 250 milligrams in 8 milliliters of liquid. And a drop factor of, let's say it's 18 drops per milliliter. Both of these items here from the label give us equivalencies. This is saying 250 milligrams of medication is equivalent to 8 milliliters of fluid. This one is telling us, the drop factor is telling us 18 drops of fluid is equivalent to 1 milliliter. That one's a little trickier because it's drops per milliliter. You have to remember that's drops per 1 milliliter. So now we start with our doctor's orders. 4,000 milligrams over 16 hours. And I should tell you, we want this in drops per minute is the way we need to set up our IV for this case. So I've got the 4,000 milligrams over 16 hours. We need to change the hours into minutes, and we need to change milligrams into drops. Well, it's not going to be a direct conversion from milligrams. Let's see what we can do. The hours are going to be a single step, so let's do the hours first. The hours are on bottom, so I put them on top to cancel them out. 1 hour is 60 minutes. The hours cancel out. We now have milligrams per minute. Well, the minutes are what we want. We do want minutes in the denominator. We have to get rid of those milligrams in the numerator. So they're in the top, we're going to put them on bottom. Our relationship, we have milligrams related to milliliters, 250 milligrams to 8 milliliters. Our milligrams are now canceled out. We now have milliliters on top and minutes on bottom. We're closer. We want to get rid of those milliliters because we want drops in our numerator. So milliliters on bottom. We have 1 milliliter is equivalent to 18 drops, or 18 drops is equivalent to 1 milliliter, however you want to look at it. So the milliliter cancels out. And now we're going to do some multiplying here. 4,000 times 1 times 8 times 18 drops. Gives us 576,000 drops on top. On bottom, we have 16 times 60 times 250. I believe it was 24,000. Oops, sorry. Missed that one by a bit. Should be 16. Let's try that. 16 times 60 times 250. 244,000 minutes. If we divide that out now, 576,000 divided by 244,000, we get 2.36. I'll move that down here. That's 2.36 drops per minute. We would probably round that to 2.4 drops per minute because most of our machines go down to the 10th of a drop. Okay, so that one, kind of a lengthy problem, but that's where we left off on Wednesday. Let's take the next step. Sometimes the doctor has orders that depend on the needs of the patient to be judged by the person administering the medication. Let's say the doctor orders 5,000 milligrams to 8,000 milligrams over 8 hours, depending on pain needs. So you can increase the flow or decrease the flow depending on the patient's amount of pain, so their comfort. Let's look at our label. So our label on this one is going to say 50 milligrams in 2 milliliters and a drop factor of 15 drops per milliliter. So here, because there's a range, 5,000 to 8,000 milligrams, we're going to have to do a minimum and a maximum flow rate. So I'm going to start finding the minimum flow rate. And we are, once again, looking for this in drops per minute. So we're going to start out with what's given here. 5,000 milligrams is our minimum because we're doing the minimum flow rate over 8 hours. Now, a similar process to what we had before. We have to get rid of the hours because we want it to be out of minutes. So hours are on bottom. We put them on top so they cancel out. 1 hour is 60 minutes. The hours are now gone. We now have milligrams per minute. Now we don't want milligrams, we want drops. So let's get rid of the milligrams. They're on top, so we're gonna put them on bottom. The only thing we have of milligrams is the 50 milligrams in 2 milliliters. That's 50 milligrams, equivalent to 2 milliliters. Milligrams are gone. We now have milliliters on top and minutes on bottom. Well, we want to get from that milliliters to drops here at some point. Let's get rid of the milliliters. Now we do have a link between drops and milliliters. 15 drops equals 1 milliliter. So the milliliters are gone. And now we do have drops in the numerator and minutes in the denominator. So we'll go ahead and multiply that out. Now I'm going to take a shortcut here. I am going to cancel out 1 0 here, here. So I cancel out 2 zeros up here. Just to make it a little bit easier on me, not quite as big of numbers. So I've got 50 times 1 times 2 is 100 times 15 is 1500 drops. On bottom, I have 8 times 6 is 48, times 5 is 240, and that is minutes. So let's divide that out. 1500 divided by 240. 6.25 we get as drops per minute. Probably round that to 6.3, but I'm leaving it at 6.25 right now because I need that to do some calculations. Now, I could go ahead and redo this whole calculation for that maximum amount of 8,000 milligrams over 8 hours. But I know those dosages are proportional. So I can perform something called a titration. What a titration does is it allows us to take two values that are proportional and adjust them. So here we had the minimum, 5,000 milligrams, gave us 6.25 drops per minute. Well, that has to be the same proportion as if we use the 8,000 milligrams as our maximum. That'll give us drops per minute here that should correspond to the maximum dose. So just do times 8,000, or 8,000 times the 6.25 divided by 5,000. So, and I can just do times 8 divided by 5 because the zeros cancel out. 6.25 times 8,000 divided by 5,000 gives us 10 drops per minute. So rather than having to do this whole calculation again, that titration allows us to just set up a proportion and get that larger value. So this is saying that we're allowed to run that IV anywhere from 6.25 drops per minute up to 10 drops per minute, depending on the patient's comfort and pain level. That type of calculation happens quite a bit. A titration can occur in a lot of different forms. Another form it might take, the doctor might order a medication to be given, and I don't remember the abbreviations real well, so I think it's Q6H, but we're just going to say every 6 hours as recommended on the label. So they're saying read the label and give the recommended dose every 6 hours. Well, let's say we look at the label, and the label says to administer 400 milligrams every 8 hours. Well, there's a problem there. These two dosages, these two time frames don't match up, but the dosages should be proportional. Now, we can't just blindly plug numbers in. We do have to think about it a little bit. So I'm going to compare my 6 hours to my 8 hours. Now, even though the 400 milligram dose goes with the 8 hours, I do have to think, if we're going to give it at a shorter time, are we going to give a smaller or a larger dose? What we're asking, is this a direct relationship, or is it an inverse relationship? In a direct relationship, when one number gets bigger, the other number also gets bigger. In an inverse, if one number gets bigger, the other number has to get smaller. Well, here, the time between doses is one of the numbers. The other is the size of the dose. If the time between doses gets larger, the size of the dose can get larger. You can give them more if you wait longer. So it makes sense for the bigger number to go with the bigger number. So that means the 400 milligrams over 8 hours, the 400 milligrams is going to stay with the 8 hours on bottom. Now we'll cross multiply and divide. 6 times 400 divided by 8. Well, 6 times 400 is 2400 divided by 8 is 300. So what that's saying is if the doctor wants you to give that medication every 6 hours instead of every 8 hours, you can adjust that dosage to 300 milligrams per hour. So that is, like I said, that's called a titration. And we will look at titrations more as we start looking at dosages based on weight, dosages based on body surface area, and other items like that. So let's take a look. I mentioned it. Let's take a look at that right now. Dosages based on weight. Now we'll put in parentheses there, or mass. Now for the metric system, we're tending to focus on mass. Many of our doses, if you're looking at the labels, again, we saw that last problem, the doctor just recommended give the dosage as recommended by the manufacturer or whatever. Many of those dosages give something like this. It might be 200 milligrams per kilogram per day of a medication. So that means is for every kilogram of mass, you can give them 200 milligrams per day. Well, to deal with this, we need to first know the weight or the mass of the patient. So if we have a patient that is 40 kilograms, that's about 88 pounds, if you're wondering. So a 40 kilogram patient, we need to find what is their recommended dose. The time frame is going to be this number right here, that's per day. So we are going to know that we're looking at a day is our time frame. So we're going to ignore that for now. We're going to take our 40 kilogram patient and we're going to use this label to convert that into a dosage. This is 200 milligrams per kilogram, means that is 200 milligrams per 1 kilogram, like that. We can use that as a conversion factor. Kilograms cancel out. $40 times 200 is 8,000 milligrams. On bottom, it's just 1. So what that is, we got to bring back in our time frame, that is 8,000 milligrams per day. Okay, so let's take a look at a little bit more complicated version of that. We might have a label. Again, we're ordered to give as instructed label might say 800 micrograms per kilogram every 4 hours. We might have a patient who weighs 99 pounds. The first thing we need to do is we need to convert our patient into kilograms, because this is per kilogram. If you recall from last unit, we have a very quick conversion from pounds to kilograms. That was that 2.2 pounds is equivalent to 1 kilogram. Now that's not exact, but that's close enough. We can go ahead and do dimensional analysis. Put the 99 pounds over 1. 2.2 pounds goes on bottom, 1 kilogram on top. And that ends up giving us, pounds canceling out, 99 kilograms over 2.2. 99 divided by 2.2 is 45 pounds, or 45 kilograms. Now, this is a conversion that we do enough that I won't make you do out the dimensional analysis like that. We know that to get from pounds to kilograms, it is simply dividing by 2.2. So when we see 99 pounds, we're just going to divide by 2.2 to get the 45 kilograms. So anyway, we've got the 45 kilograms. Let's work from there. So we put that over 1. And again, we're going to ignore the time frame here. We're going to remember it because we need it later. But for right now, we're going to ignore it. We're going to work with that 800 micrograms, I should say, per kilogram. Now, kilograms are on top, so we got to have them on bottom here. That's 1 kilogram is equivalent to 800 micrograms. Kilograms cancel out. 45 times 800 is 36,000 micrograms over 1. Now, there's two things I'm going to do here. One is 36,000 is a big number, and micrograms is not our typical unit. We're going to turn that into milligrams. To get from micro to milligrams, it is 3 spots to the left on the chart. So I move over 3 spots. That is 36 milligrams. Second, I need to put our time back in, which is the per 4 hours. So that's 36 milligrams over every 4 hours. Just like with our last example in the IVs, we can have a range given. Some of these bottles might say 0.4 to 0.6 milligrams per kilogram per every 8 hours. Might have a patient who's 132 pounds. So our first thing, again, I'm not going to bother setting up the dimensional analysis. I'm just going to do 132 divided by 2.2. Gives us 60 kilograms. So this patient is 60 kilograms. We start off then our dimensional analysis with that 60. So 60 kilograms. Now I'm going to pick one or the other. I'm going to start with the smaller one, which means I'm calculating the minimum amount here, which is using the 0.4 milligrams per kilogram. I want to get rid of kilograms, so kilograms go on bottom. 0.4 milligrams per 1 kilogram. My kilograms are going to disappear. 60 times 0.4 is 24 milligrams over 1. That's 24 milligrams per 8 hours. Every 8 hours, we can give 24 milligrams would be the minimum dose. To get the maximum dose, we use that ratio, that titration. We had 0.4, but we could go up to 0.6. The 24 milligrams every 8 hours would be that smaller amount. We cross multiply and divide. 0.6 times 24 divided by 0.4, we get 36 milligrams. So that means we can go up to 36 milligrams every 8 hours and still be within that safe range. Well, let's take a look at, that titration, it helped. It saved us a little time, but really this wasn't that long of a calculation. We could have gone back and just redid the calculation for the larger number. But sometimes there are more steps involved. Let's take a peek at one like that. So let's say that our label says that it recommends 80 micrograms to 100 micrograms per kilogram per hour. Also on the label, it states that this medication is concentrated at 25 milligrams in 8 milliliters of fluid. Now we still need to know our patient. Let's take a patient who is 143 pounds. So I need to convert them into kilograms first, dividing by 2.2. Gives us 65 kilograms. So we have a 65 kilogram patient. That is where we were starting with our calculation. Once again, we're going to do the minimum. We're starting with our 65 kilograms. Put it over 1. And our minimum per kilogram was 80 micrograms. So the kilograms cancel out. Now, we notice here that we have 25 milligrams to milliliters. So we're going to have micrograms here. We're going to have to do a conversion. We know that 1 milligram is 1,000 micrograms. That's going to get rid of the micrograms, put us in milligrams. And then we also know then, getting rid of milligrams, going to milliliters, 25 milligrams is equivalent to 8 milliliters. So that's going to give us the milliliters that we would administer to our patient. So I'm going to see here if I have everything I can cancel. I can cancel out a 0 here and 1 0 there. That's probably about all I can get rid of easily here for now. So let's go ahead and multiply. We got 65 times 8 times 1 times 8. Gives me 4,160 milliliters. On bottom, 1 times 1 times 1,000 times 25 is, sorry, no, that's 100 now. I've canceled out one of the zeros. It's just 100. That's 2,500 on bottom. So we divide that out. 4,160 divided by 2,500 is 1.66. So that is 1.66 milliliters. Our time frame is per hour. So we're going to administer to that patient 1.66 milliliters per hour. That's the minimum dose. Find the maximum, I'm going to use that proportion idea again. I have 80 micrograms per kilogram. I want to bump that up to what it would be for the 100 micrograms. The 1.66 goes with the 80, so I will cross multiply and divide. 100 times 1.66 divided by 8. By 80. There we go. We get 2.08. So what that's telling us is that we can administer anywhere from 1.66 milliliters per hour to 2.08 milliliters per hour to this patient. So you can see that titration does help us. It does save us from having to go through this whole calculation again. So let's take a look at another case like that. Let's say the doctor orders after seeing a patient, orders 400 micrograms to 500 micrograms. Come on now. Per kilogram every 6 hours. For a patient that weighs 88 pounds. The rest of the label says, the label on the bottle says that this is constituted as 5 milligrams in 2 milliliters of fluid. And there's a drop factor of 12 drops per milliliter. We want to know what's our range in drops per minute to administer this medication. We're going to be administering it obviously through an IV. So first we need to get the weight in kilograms for our patient. So we take the 88 divided by 2.2 gives us 40 kilograms. So that's where we start all this mess. We're going to do the minimum first, which is the 400 micrograms per kilogram. So kilogram has to go on bottom to cancel out, so it's 400 micrograms for 1 kilogram. We do have to get our micrograms into milligrams. 1 milligram is 1,000 micrograms. So the kilograms have canceled, the micrograms have canceled. Right now what we have is milligrams. We're going to do our 5 milligrams per milliliter here. Milligrams are going to go on bottom, so 5 milligrams per 2 milliliters. The milligrams cancel. And that's as far as we can go for right now. Let's go ahead and calculate this all out. Let's see, I've got 1, 2, 3 zeros. I'm going to cancel 1, 2, 3 zeros. I've got 4 times 4 is 16, times 1 times 2 is 32 milliliters. On bottom, 1 times 1 times 1 times 5 is 5. That's 6.4 milliliters. Now we need to put our time frame back in. That is per 6 hours. So that's 6.4 milliliters every 6 hours. Now we have to convert that into minutes. I know we're getting some ridiculously small numbers on this one. 1 hour is 60 minutes. So my hours are going to cancel out. That'll give me milliliters per minute, and I do have to bring in my drop factor. 12 drops per 1 milliliter. That'll cancel out the milliliters. So what do we have here? We got 6.4 times 1 times 12. 6.4 times 12 is going to give us 76.8, I believe. That's drops. On bottom, we got 6 times 60. Minutes is 360 minutes. So we divide that out. 76.8 divided by 360 gives us 0.21 drops per minute. So again, that's an incredibly small number or low rate. But the math, the process is still pretty pure. Well, that's our minimum amount. To find our maximum amount, we know that was for 400 micrograms. Let's look at 500 micrograms. So at 400 micrograms, what would it have been if we had used the 500 micrograms? Well, I can put the 0.21 drops per minute with a smaller number, and I can cross multiply and divide. Times 500 divided by 400 gives us 0.266, so 0.27 drops per minute. So for this patient, that gives us a range of 0.21 to 0.27 drops per minute of that medication. Any questions? So you can see these calculations can get quite extensive. Up here when I did this calculation, I did the 40 kilograms. I waited to put the hours back into the calculation until after I got to milliliters. I actually could have done that at any point. I could have put the 6 hours back in. I would have to stop the calculation and then adjust it to put the 6 hours in, but I could have done that at any point after I started. I just waited till I got to milliliters. But before we can consider a drop factor, we do have to have the time in our calculation. So let's look at one more example. So let's say that a doctor orders 5 milligrams to 8 milligrams of medication per kilogram for every 2 hours. The label says that we have 10 milligrams in 5 milliliters, and a drop factor of 18. It's 18 drops per milliliter. Our patient is 99 pounds. So once again, we're going to change that patient by dividing by 2.2 into kilograms. Give us 45 kilograms. So a 45 kilogram patient. We want our answer here in drops per minute. Now obviously it's going to be a range again. We're going to start out with the minimum again, the 5. Take our 45 kilogram patient. And we'll go ahead and do 5 milligrams per 1 kilogram. Kilograms are going to cancel out. We have milligrams now. Now, like I said, I can put the time in there at any point. I just have to finish the calculation and put in the time. I'm going to do it right here this time, just so you can see how it can be different. 45 times 5 milligrams is 225 milligrams over 1. Now, if I put in that 2 hours, that's saying it's 225 milligrams over 2 hours. So I would start the rest of my calculation with that number, 225 milligrams over 2 hours. And now I'll go ahead and put in, I want to get rid of milligrams. I have 10 milligrams in 5 milliliters. Milligrams are gone. I want to get rid of my milliliters. And I have, what is it, 18 drops per milliliter? Yes. So 18 drops in 1 milliliter. So my milliliters are gone. So that does have me in drops per hour. I got to change my hours. I should have done that somewhere along the line. I can do it here. 1 hour is 60 minutes. The hours will be gone. So now I've got, see anything to cancel? Not really. So 225 times 5 times 18 gives me 20,250 drops over 2 times 10 is 20 times 1 times 60 is 1,200 minutes. Giving us 16.875 drops per minute. Now, normally we'd round that to 1/10 of a drop or 100th of a drop or whatever, depending on our equipment. Right now, I'm leaving that exact because I'm going to use that in a titration to find. If I used the 5 milligrams as my minimum, let's find what it would be for the 8 milligram maximum. So that 16.875 goes with the smaller dose as drops per minute. We'll cross multiply and divide. Times 8 divided by 5. Which gives us 27 drops per minute is our maximum dose. So we'll go 16.9 to 27 drops per minute is the range of that dose. Okay, we will talk about these more once we come back from spring break. For right now, page 178 to 179 in your book, 1 through 21 the odds, talks about those IV flow rates. Page 188 through 190, 1 through 21 the odds, talks about the dosages based on weight. Then just a little scheduling thing. Next week, there is no class. I am out for spring break. I have some high school visits I have to do for some other classes I teach. So there will be no class for this class over spring break. So the next time we meet, our next class will be on March 26th. Medford, did your school board decide whether you're going to have class on April 2nd or not? On Monday? Okay. Okay, so that looks like at least 2 out of 3 of you are in class on that Monday, April 2nd. So we'll definitely be having class on Monday, April 2nd. On March 28th, 2 out of the 3 of you guys are out of class. So on March 28th, what we'll have is we're just going to have kind of like an application day. Medford, I believe you guys are the only ones in class that day. So we probably won't use the whole class, so bring in other homework with you that day. And I'll mention it on the 26th, I'll remind you. But we'll just do some extra applications for you so you can see some extra examples and stuff like that. But bring in some other work with you because we probably won't fill the whole hour because it'll just be you guys that day. Okay, you guys have a great week and we will see you on March 26th.